This is our boardroom that we just walked through here. Now we're coming into the actual work center. These are the 30 kilowatt micro turbines that we have running on the Bronco site. And these units that we're looking at here will be the ones that are going to the harvest sites. This is a homemade load, simply a hot air furnace that we've added some electrical loads to so that we can put a load on the equipment when we're testing it. This canister here is filled with gas. That's what we run these units off of. And this is where we mix the different types of gases, propane, methane, butane, and run our equipment on them so we can make sure that our emissions and our equipment is going to run properly. This is the local computer interface where we monitor the equipment that's in our shop. At the beginning of this video, I had showed you the web interface. Now, this is the equipment that is waiting right now for the sulfur valves that we will be putting on in order to facilitate the #1 site with harvest, the Chincooley site. This facility is 10,000 square feet. This is our next pieces of equipment here. These are the solar Spartans, they're called. We have 3 of them sitting here. 1, 2, 3. They're not anywhere near. We haven't even started working on them, as you can tell just by looking at them. This is the back end of one, the generator end. This is the front end. That's the turbine inlet. This is our hydrogen test unit here. This is where we pump our hydrogen into and run this unit. And we discover whatever we can discover in regards to the utilization of hydrogen as a combustion enhancement. This is actually a 2.5 liter Ford natural gas engine. And if I zoom in on it, you may be able to see, no, I don't think it's all on the other side, the various connection apparatus that we have in order to monitor just about every point of contact on the engine. These, and I'm showing you right here now, these are recuperators. These units will be redesigned and put on those units there, the Spartans. And this is where we will change from having 10 30 kilowatt units or 20 30 kilowatt units, say on the harvest site, to 3 of those units there. So 3 of those equals, can't really see that one there, but say 30 of these. So you can see why we would prefer to go with the Spartan unit. In order to make the Spartan run efficiently, these recuperators, which we just actually unloaded about 5 minutes ago, we just bought these and brought them in. These are used recuperators, but the design is intact. We will rebuild these 3 for use on those 3 Spartans, and in the course of doing so, we will design our own recuperators for the Spartan units. These 3 are not. This one here, this is for an 800 kilowatt solar Saturn. These 2 here are both for 100 kilowatt units, and this is for a 200 kilowatt unit. But these are all working recuperators. And this is what we will be designing next that will give us a high competitive edge in the industry. Nobody else has them. These are the buildings that the generators go inside of when they go in onto the field. I think we have about 40 of these buildings in here right now. These generators here are all sitting in front of their respective buildings that they'll be placed inside of as we outfit them and get them ready to go. All these units have been tested and are, well, I'm going to say use the word certified by us as field ready. As soon as we have the sulfur equipment to go on and re-outfit some of the valves, they'll go into the housings that they're sitting right in front of, and then they'll be shipped out to the Harvest Chincooley site for service. That's what the unit would look like when it comes directly from Capstone, brand new say, inside of a small housing like that. We take that housing off of them because it serves no purpose for us in the field, and put the generator, as you see it here, inside of these buildings. So that's our shop here. We just took a walk through. These are battery packs. This is what actually fires the units up. There's 48, I believe, of these to each unit. So you can see just how one of these units operates. I'm just going to stop this video for a minute, and I'm going to fire up this turbine right here so you can watch it in operation. Just firing up now. Those are the batteries that are now spinning the turbine, getting it ready to fire. No load on this currently. It was just going to go into an idle mode. And now we're going to put a load on this unit, just as if you were firing up on the Bronco site with this unit, and going to run some pumps. We're actually feeding electricity into the grid here right now, so we won't say that out loud. This engine is now pumping out 10 kilowatts. What would the RPM be on this right now, Rich? RPM. And it's as simple as that.
Averaging about 1100 degrees Fahrenheit temperature.
1100 degrees Fahrenheit exhaust temperature. Now we were talking about cogeneration on the phone the other day, Blair and I.
Now that's combustion temperature.
Combustion, okay.
It's a constant temperature, variable speed engine. The temperature is always around 1100 degrees Fahrenheit. If it goes above or below, it shuts itself off.
Okay, end of video.